finished with our Mr. Robot CTF, and we had talked about told you about a war game known as the website for those war games is this Over the Wire, and the war game that I mentioned was this Bandit. Okay, this is the first one. So let's see how far we can go into it. So how many levels did we cover yesterday? I don't think we did a lot in this case. Level 6. Okay. So we had reached level 6 or we had finished level 6? Okay. In either case, I'll just do this level again. No worries. Okay. So logging into level 6. So the password for level 6. Okay. Now for this level, it says that for the next level, the password is somewhere on the server and has all the following properties. It's owned by this particular user, Bandit 7. It's owned by the group, Bandit 6, and it is 33 bytes in size. Okay. Now, if I just do what I did previously and look by file size, so find this and 33C. Then in this case, I'm actually going to get a lot of results. But there is a way to narrow it down. I can simply say user Bandit 7 and group Bandit 6. Okay, so that's just, it will give us the required file, and this file is appearing in these results as well. What if this was somewhere in the middle of these results? You can't expect to look through all of those files. So to find the password for the next level, copy this, simply cat it out, and this is the password for level 7. So you can copy this. Now what I can do here is SSH. Okay, no, exit. I think Bandit 7, and I can simply log in now to the next level with this password, and we are in. Okay, I would recommend that you guys try this out on your systems as well by your own. Now, it says that the password for the next level is stored in the file data.txt next to the word millionth. Okay, so let us see. Okay, there is this file .data.txt, but if I go on to see this file, it's actually a large file. It has a lot of stuff. Okay, and it's a very large file. So manually combing through the entire file is out of the question. So what command can be used here?
Grep command, sir.
Grep command. Okay. So cat. Okay, you don't need to cat grep. And okay, what syntax will I use for grep?
Grep and the word name, the word which we want to search for.
So
Then
grep
file name.
millionth. Okay,
Then file name.
file name, and that's our required password. So I'll just copy this, exit, log in again to the next level. Okay, so the password for next level is stored in the file data.txt and is the only line of text that occurs only once. Okay, let's see the file. Okay, so we have the file data.txt. Again, if I try to access it, I'll see that this is quite a large file. So I'll have to rely on some kind of Linux commands to help me out here. So what do I do in this case? No, no ideas. Okay, so pay attention to what is written. It says that the password is the only line of text that occurs only once, which means that everything else, every other line is occurring repeatedly, or at least every other line is occurring more than once. So what I need to do here is I need to just filter out every piece of data that is not unique, that is occurring more than once. So there is a command in Linux known as unique. So, okay, if you take a look at what it does, it filters adjacent matching lines from input. Matching lines as in lines that are repeated. Okay, there's one other thing here. And in the options, you can see there's an option unique hyphen u, which will only print the unique lines in the data that you give it. So we could use this. Now what I can do is cat data.txt. pipe it to unique, use hyphen u. However, when we use this, okay, this is not really giving us just one line of data, it's giving us a lot of stuff. So this did not work. Can anyone tell me why?
I think all these lines are unique. They are only once written in the page. Only they occur only once. That's why it found it as unique. Every line is unique.
These lines are not repeated, but it's telling us, the hint is saying that the line we need is the only line that occurs once. Every other line is repeated throughout the text. And since that is, they're not lying here, that is true. So there must be something, something must be the issue with what we're doing here. Okay, I'll tell you. See, when I looked at the manual page for this, see what it says. Okay, pay attention. Filter adjacent matching lines from input. Focus on the adjacent. So what this means is, if one line is occurring twice consecutively, then that will be filtered out. But if that's not the case, then unique is not going to filter that out. So what we do is, there is another command, and they've also mentioned it here, called sort. What sort is going to do? Go through the entire list, perform sorting, and when a file is sorted, then every line that is repeating, so let's say a line is occurring 3 times throughout this entire text, then after sorting, all those 3 occurrences will be clubbed together. And this is going to be the case for every piece of text that is repeated. If something is repeated 5 times, all those 5 occurrences are going to come together. If something is repeated twice, those 2 occurrences are going to be printed together. So to this command, we can add another command called sort. We'll need another pipe to, so if I run this, that gives me a single piece of text, which is the required password. So what we did here was, cat outputted the contents of this file. We piped that output to the sort command. So it sorted the file. Now we ran unique on this file. So we also specified the hyphen u option, saying that we only wanted to output the lines of text that are unique, that occur only once. So it filtered out everything that had more than one occurrence, and we were left with this one line, which is the password that we need. Okay, so this is clear what we did and why it worked. Okay, so now this is, so we've already received the password for this level. Now I can copy this, exit here, and go on to the next one. Paste. go back to this, see what we need to do in the next case. Okay. So the password for the next level is stored in the data.txt in one of the few human readable strings preceded by several equal to characters. Okay. So we should be having a file called data.txt, and if I try to view it, so it's a binary file, it says. Okay. So it is mostly binary stuff which is not for us to understand. Now, how can I proceed in this case? What kind of commands can I use? What kind of approach should I take? See, it, whenever you get a hint, okay, always read it carefully. So here it says that the password is stored in this file in one of the few human readable strings. The human readable is the keyword that you need to pay attention to. So first, we'll need to figure out how to get human readable strings. Now they have mentioned a few commands that we'll need to, that may help us in solving. Grep is not going to help, sort is not going to help, unique is not going to help, but strings is going to help in filtering out human readable strings from a file. So strings, again, if you want, you can take a look at the manual for it first. So it says that it's used to print the strings of printable characters in files. Okay, so you can use this on a file, which is okay, data.txt. Now this is, giving us human readable strings rather than binary data, but it's still a lot. So now what can I use to filter out my results? See, we already used strings to filter out the human readable data. All we need to do is pay attention to the second part of the hint, which is that it is preceded by several equal to characters. So what command can I use to further filter out my results? I can simply use grep. See, I use this. I can say I want to further filter it, grep, and it says it is preceded by several equal to. Several means definitely there's going to be more than one. So let's say just we add two, and okay, we see four things here. The password is, and this is the password. So I'm going to go ahead with this and log into the next part. Now let's see what we are supposed to do here. password is stored in data.txt, which contains base 64 encoded data. So this is base 64 encoded. So all we need to do is decode this. Now base 64 is an encoding algorithm. So we can simply decode it using the base 64 command. Or I could say base 64 hyphen d for decode data.txt, and it has given us the decoded data. So this is the required password. So the next one, it says that the password is stored in data.text, where all lowercase and uppercase letters have been rotated by 13 positions. And the helpful reading material mentions something known as rot 13. So if you're not familiar with this, it is basically a very simple substitution cipher which shifts characters by a certain number of spaces. So in this case, they've shifted by 13 spaces. So that means A becomes N, B becomes O, so and so on. So if you're writing hello, it becomes this, H changes to U, E changes to R, because every letter is replaced by its partner 13 characters further along the alphabet. So if you're writing A, it becomes A plus 13, which is N. So if you're writing ABC, your cipher text would become NOP. So they are saying that in this case, this data.txt has been converted to rot 13. See, you have two options here. Either you go to a website like rot13.com, copy this thing, paste it here, and it will decode it for you. So this would be your required password. Or what you can do is use a command line tool known as tr or translate, and now you need to specify what translation to perform. So we need to specify here the character sets to use. Now since this text has a combination of both uppercase as well as lowercase characters, so I'll say A to Z and lowercase as well. So this is the original character set, and now we want to translate it to a different one. Now we saw that with the rot 13, A becomes N. If you shift it by 13 characters, A becomes N. So our target conversion is we want to change A to N. So N. Now we could, if I were to write N to M here, this is not going to work because we need to stop at Z and then start again with A. Okay, so after you start from N, you reach the end Z, then you loop back to A. So for that, you need to specify this A to M as well. If you directly specify N to M, it's not going to work. And this exact same thing we need to do for lowercase as well. So we can just say A to M and double quotes, and you receive your desired answer. So just copy this. Okay, you have your next level. Go back here, see what to do next. Okay, so it's okay. This one is interesting. It says that the password for the next level is stored in the file data.txt, which is a hex dump of a file that has been repeatedly compressed. Okay, for this level, it may be useful to create a directory under temp in which you can work using make dir. Okay, so it's simply saying that you create a directory under temp and work there. Copy it using cp, rename it using mb. Okay, so what we do is we go to temp, because see in this directory, if I just try to work here, I will not be able to do anything on this file directly anyway. You can just read it currently. So what I'm going to do is I'm going to go to the sorry, not tmo, temp directory. Now in any case, when you are working on another system, when you have shell access on some system and you want to create some files or download some files or put any kind of files there, you want to upload something, then you need to work in the temp directory, because nowhere else on the system will you have any permissions to do anything. So you need to work in the temp directory. Now in temp, let's create a new directory. Yeah, new file exists. Okay, I think I created this earlier. Data. Okay, let's remove this one and copy. And I'm just going to name it as data. Now if I try to view this data, okay, this is the format that the data is in currently. So like the hint mentions here, this file is a hex dump of a file that has been repeatedly compressed. Okay, so this is the hex dump. This is all in hexadecimal, and it's also like showing you the non-hex dump format. But okay, the first thing we need to do is convert this hex dump to the actual file. So what can we use in this case?
tar hyphen xpzf and file names. Not wrong.
Tar is used for extracting a tar.gz file, but that kind of thing is not possible currently. Currently, we have this hex dump.
Okay, sir.
Okay, so I cannot work directly on a hex dump. I need to first get a file from it.
Yes, sir.
So now there is a command. Okay, this they have also mentioned on the hint page. There is this command called xxd. If you look at the manual for it, it says that this command is used to convert a file to a hex dump or perform the reversal. So I want to reverse this hex dump. So xxd hyphen r for the reversal process, and the input will be our data file. Okay, I need to actually store this. I'll just call it new. So I have a file called new. I can remove this data now. Now, if I check what kind of file this is, it says that it's gzip compressed data. So what do I need to do now?
G unzip, sir. G unzip.
Gunzip.
Unzip.
Okay, unzip and the file name. Okay, so new, but it says there's an error, unknown suffix. So what can I do now in order to make sure that gunzip is able to work with this file? Gunzip only works with files which have the extension of gz. So simply I can say I can rename the file new to data.gz. Data I've just kept because I want to keep that as the name. It doesn't matter what the name is, just it needs to have the extension .gz. Okay, so okay, now we have an archive which we can use with gunzip. And if I check what files I have here, okay, I'll see there's something known as data. Let's check what this is. Now it's saying that it's bzip to compress data. So what command do I use here?
Not sure, but might be B unzip or something else.
B
I forgot.
unzip to, and I need to provide the file which is data. So it says can't guess original name for data using data.out. So we have this data.out now. Sorry, not dial, file data.out. Again, it's saying use of compressed data, so we need to rename it to g and g unzip data. Now it's saying it's a tar archive. So what extension do I give it now?
GZ dot GZ. Oh, it's already.
.gz was for gzip compressed data, but for a tar archive, what's the
Dot tar. Dot tar, sir.
.tar? Okay, data dot tar. Oh, you have to specify the source and destination. I forgot to mention the source. Okay, we have data dot tar now. So how do you extract this?
Tar XVZ of tar space XVZ of.
Tar x vf is fine. This is for tar.gz, not
Okay,
destination
sir.
tar files. Data dot tar. Now you receive a bin file. Okay, so check it again. What this is? Data 5. Okay, it's again a tar archive now. One thing I need to do is remove the earlier tar and rename the data5.bin to data.tar again. Again, I can use the same tar command, data6 now. Okay, now it's bzip to compress data again, bunzip. another tar archive. So we'll simply rename it to, can use the same tar command again, data 8 now. These are, now it's simply data. Okay, so it says that this is ASCII text now, and this is our final password. So this was like it said, it was repeatedly compressed. So every time we uncompressed it or decompressed it, we were getting closer to getting our password. Now you will see this kind of situations in some CTFs. So if you don't get the answer by one extraction, then you need to check what kind of file you have, and accordingly you may need to rename it or perform other kinds of functions on it. So the file command is very important, as we've seen in this case. Without it, it would have been difficult to figure out what kind of file we are looking at. So it gives us the password to the next level, and we exit. Okay, it says that, wait, correct one. Yeah, okay. So it says that the password for the next level is stored in this file and can only be read by that user. So for this level, you don't get a next password, but you get a private SSH key that can be used in to log on to the next level. Okay, so if I perform, sorry, ls, then it shows that there is a file known as sshkey.private, and we can, this is not directly a password, is it? It's a private key for SSH. So what you can do here is, okay, you can see this is how a private key is stored. Now what we need to do here is simply use SSH and log in as Bandit 14 at localhost, since we are on the server itself currently. But we don't have the password. However, we have this private SSH key for this Bandit 14 user. So I can provide that as an input. Okay, and I can connect. So now we are logged in as this Bandit 14 user. So in SSH, you can either connect using a password or you can connect using the private key file. Now, of course, you're not going to find private key files just lying about anywhere on a system. But if you do, then that can be used to log in. Now, okay, that's it for today's session.